Welcome to a new and interesting experiment here with a voltage regulator. Its name is LM317. Here I have it's a pinout, the name 317 LM, and here the first is adjust, the middle is V out, and the right one is voltage in or input. And here is the input receiving the voltage on this pin here. In the middle is V out here on this 10 kilo resistor, and the adjust is also a 10 kilo resistor. Very simple circuit here. And also some power LEDs. These are this kind of LEDs. I have a ton of them that I scrapped from light bulbs. So burned LEDs, it says here, but not completely. And super weak at 8.2 volts, about 6 milliamps. Let me show you from this kind of boards. I literally cut them because it's aluminum with this kind of cutter. Is a metal sheet cutter, and it's quite precise and is not bending or cracking anything. If you are careful, little by little, you can actually cut this kind of shapes that I'm having here. So that's how I did it. And this is what I'm having here. Right now, I'm having two of 10 kilo. It's 10 kilo and 10 kilo, as you can see. I zoomed in to actually read the values of the resistors there. Right? One is a little bit fucked up, but you can see it's still a 10 kilo. Here I have the circuit diagram. Let me zoom in. I tested this specific LEDs that I'm that I'm having here. You see, I numbered them C and D, and this is A and B, and this is A and B, and I test them each LED by itself, and it gives me 7.2 volts when opening. I should film this opening at this voltage, but it's when it is barely starting to lit up. That's what is happening. So I increase the voltage, nothing. It was like this, dead, and I increase the voltage until I could start to see something flickering there, a little bit of light, and then after I've seen that little bit of light, not like it is right now. So very dim. I put down the value. So at this value, they started to lit up, to enter in conduction, pretty much, to start conducting and also lighting. And this is the circuit that you are seeing here. Not this one. This one was the start one, the start circuit. Actually, this is by the book from the datasheet. But my circuit that I'm having here is a bit more better, especially for low current LEDs or whatever low current loads you have, consumers there. In this case, are LEDs. I will show you what I wrote here is in English, and the idea was to control it very well, current through these LEDs, and to create a constant current regulator. I just put that very important naming there. It is a constant current. It's not fluctuating. It's not going up and down as I'm turning the voltage. As I'm changing the voltage, like as a resistor. So here is the maximum. You see these two knobs, they are designated for the voltage, these two. And these knobs are designated for the amperage. Yeah, there. So these two for voltage, and these two is for amperage. And the amperage is kept in the middle there for both of them. But here are maximum. So my power source is maximum 32 volts, absolutely maximum. I cannot move them more than this. If I'm doing this, it's going down. So I'm keeping it at maximum. And if I'm changing the volume now, if I'm going down, you see not quite much is happening. Now it's happening now. And now I'm at 16. But these LEDs, as you can see, they are starting at 7 volts, but they start dimming out at 16. So probably these are actually 8 volts, as I written here, 8.2 volts at 6 milliamp. But probably I made some tests until I got the best luminosity out of these LEDs, and probably this is the value that was left here, not this opening when they are starting to lit up. So that's so it doesn't matter the voltage that I'm changing there. They are maintaining a constant current through them with this little tiny setup, and that's very interesting. I had to really test the shit out of it until I managed to understand how to do it. And this is a better circuit what I did here. Probably they omitted it in the datasheet. They link this adjust directly to there, exactly like here. They are linked like that. But this is a problem, especially for low current elements that I'm having here, consumers. Let's do their experiment, their circuit here. I will actually omit that V out and only link the adjust, like here. You see, only the adjust. I will link it to the two LEDs and to ground and see what's happening, because this was very tricky for me until I managed to understand it. Make abstraction of this and this. This is the actual circuit that I will make right now. So I'm already powering the regulator through that link there. The voltage is at 16, but I will turn it on 32 immediately, and you will see there is no difference. And let's put this link between adjust and whatever, between adjust and the LEDs. So this is the rail for the LEDs, and the first pin there, here and here. Ta-da! Check this out. So I'm only powering the adjust, so the V out, the voltage out of the regulator, is not really connected to anything. So exactly like I'm having it here, not connected. It's floating in air. So now this adjust is actually powering this power LEDs. So they are receiving a default current and a default voltage over them. So now let me increase the voltage. And You see, now is 32, as you can see, is the maximum. And if I'm going down, 19, 16, now up again, 23, 28, 32 again. So you see, there is a slight difference, a little bit, but pretty much it is a constant. It's kind of a constant current that is maintaining, and also voltage probably. It definitely is a constant voltage here. On my camera, actually, let me wipe it a little bit, clean it. Now it's better, yeah, because it's creating those flares, and my LEDs are not really that bright. You see, these are extremely bright. They are blinding you. But right now I'm driving them at a very low current and very low voltage through this setup that I'm having here. The voltage, that voltage, if I'm applying that voltage over these LEDs, I will burn them directly. But through this setup, so if I'm connecting this point to the positive rail here, boom, kaboom, kadaboom. So this was a very important discovery for me until I scratched my head quite some time until I realized there is a default, this kind of default current and default voltage that is passing through the adjust pin alone, and it's able to power whatever you put there. So the next logical circuit or arrangement or setup, I put another value, another high resistance on the adjust pin as well. So what I'm having here, this is the classic current constant current regulator circuit in the datasheet, from the datasheet, okay, without minus these two LEDs. They only show and minus this capacitor. They only show the voltage regulator, this resistor, and how to link this adjust pin here, and that's it. And my version is a bit better than that because I can tweak this other voltage from the adjust pin as well through this whatever value I will put here. In this case, in this circuit diagram that you are seeing here, I've noted 10 kilo, but I can put 100 kilo. I actually tested with 1 mega and with 10 mega. Yes, that high, and they still lit up. Believe it or not, they still lit up. Unbelievable. With both of them. And only one as well, they lit up. Doesn't matter where I put it, that 10 mega, it still lit up, managed to lit up the LEDs. They are very extremely sensitive to current. They are very good LEDs, actually. Very, very good. And if you are under driving them, they will last. They have the potential to last forever. That good they are, is my opinion. So now let's build this. Already you've already seen with 10 kilo. Let me take out this guy here. I'm interrupting the current from there to there, and that's it. If I'm adding or taking out stuff from there. The only problem is if I'm connecting the V out from here to here directly with a link. That will be a problem because it will burn my LEDs. I almost did it, and they light up very strongly. Probably because I made only one blip like that, a slight contact. I didn't manage to burn them, but probably I did stress them a little bit electrically. So now I'm having 100 kilo here. I'm not sure if you can see. That's a yellow line somewhere there. It is a yellow, and also that one as well. Hopefully you can see the yellow line. Yeah, probably like this is better. So this is with orange and this is with yellow, which is 100 kilo both. And let's make the connection. So this is only connecting the adjust pin, and here when I'm adding this other value, this V out here, is getting a little bit more current, but it is still, you see, 32 volts is at maximum right now. And if I'm lowering, 30, 25, 20, 16, 17, and here is 15. So you see 15, and now let's go up, 16.5, 18, 19, 20, 22, 24, 26, 28, and 30, and maximum 32. So you see, it's not really a big difference, which is, this is telling me this is functioning quite well with this setup that I'm having here. Very, very interesting setup. And I'm proud that I discovered this little trick with the adjust pin that is letting a certain constant current through it. I'm very happy that I discovered this. This was essential, and they don't actually talk about it in any brochure and in any kind of data sheet, and they should. Or probably I'm blind and I didn't see it, but this kind of circuit I never seen it anywhere. So this is my contraption here, my experimentation, and I'm very happy that I figured it out because of this thing I could logically change these values higher and higher and then lower and lower. And if I'm changing this to 1 kilo, these two LEDs will bright extremely bright, very, very super bright they will be. So this is the way of, this is how you must change these resistors by experimentation, by looking at the luminosity that you want from your LEDs, and pretty much that's it. No calculations whatsoever. Just start from very big value like 10 mega, 1 mega, and go down 100 kilos, 10 kilo, and then from 10 kilo down, be very careful. It doesn't matter how many LEDs you have. This is another very interesting point, and let me show you something very interesting, and you will like it, and I like it as well, because this is the purpose of a constant current regulator. This is the entire purpose, and this was an entire discussion, and I couldn't understand it by myself alone from the first change of ideas with a guy on the forum. Then that his name on the forum it is, and he helped me understand a little bit better. He explained it very well actually, and I thank him for his help. Very good help. So pretty much what this constant current regulator is doing is providing, like the name is saying, a constant current through all this circuit, and doesn't matter if something is shortened out here, the current will not rise up and the LED will not burn out. So it doesn't matter, in other words, doesn't matter the voltage that you apply here on the circuit, on the input circuit. It can be even 240 volts, not alternative, but rectified. And that voltage, higher voltage, will theoretically, I have to make the test, and I will film that as well after I will make the correct test. But right now I'm playing safe at this lower voltage, which is not that low, 32 volts, is not that low, but it's kind of safe, and I'm getting very good results. So now this is the test. Theoretically, this constant current regulator should not burn out this LED if I'm shortening. So and this other LED will maintain the same luminosity. So look at how much it will increase the luminosity when I'm shorting that out, or this out when I will do the both of them. So let's do this, guy. You see, nothing, absolutely nothing, no difference. Probably a tiny little bit. I'm not sure why it shouldn't. And if I'm shortening this guy out, you see, that one remains absolutely the same, And even if I'm shortening the entire rail from one point to another, it will still remain at the very low milliamps that is right now. As you can see, my milliamps is not showing shit. It's 000. And my other friend asked me, did your ammeter broke up? And I said no, because all this testing that I'm doing here is at extremely very low amps, and probably what I'm having here is tens of amps, hundreds of amps, and here is the amps. So right now I'm under 10 amps, less than 10 amps, probably microamps. I have no idea. I have no idea, but it's definitely less than 10 milliamps, and that should do absolutely nothing here. So if I'm touching with my hands, I'm not getting anything. No buzzing, nothing. It's quite safe with this amount of current that is passing through this. So this is a very interesting and very practical, I may add, very practical circuit, and I'm very happy that I stick with it, because for a while, for a very long time actually, for a couple of weeks, I kind of leave it aside. I didn't want to look at it. I didn't know how to proceed, how to make all these tests that you are seeing here. So I couldn't imagine this setup. I didn't know how to do it, and with time I started to try something. I pushed myself, little by little, until I managed. So I started slowly and with very big values, resistor values, to limit the current as much as possible. And I started with 100 kilo, not with 10 kilo. 10 kilo for me is too low for this voltage that I'm having here at least. And I'm playing safe pretty much. I played safe all the time. And so from this point on, if I'm changing the resistors there with a very low resistance, or even if I'm doing this circuit where I'm leaving the default current flow from the adjust, the default value there, and only adding, so this V out is adding a little bit more current. In this case, where you see 2 R2, it means 2 ohms, 2.2 ohms. This is from another circuit from that guy that helped me. It was good for his circuit. So this resistor, it added a lot of current, pretty much. It didn't, I'm not sure how much it stopped the current flowing into his circuit. I'm not sure how much it helped its circuit, because it's very low value. I'm not sure. He made the tests there, and probably it was good for him. But pretty much you are leaving the default current to flow here, and from here you are programming how much constant current to remain on this side of the circuit through that resistor. Pretty much that's the variable programming resistor. With this resistor you are programming how much constant current to remain here, and that's pretty much it. And it's very interesting. I find it extremely interesting. And next test that I want to do is directly to 240 volts rectified, not alternative but rectified. And theoretically, this guy should not blow up from too much stress. I have to make some calculations, probably. I'm not sure. I'm not completely sure right now what is going on. But theoretically, if I'm powering all this setup with 240 volts, as I'm powering right now instead of that 32 volts, if I'm powering it with 240 volts, it should look and feel the same, exactly the same as it is right now. No changes at all. 240 volts rectified. So that's the next test that I want to do. And if I will manage to lit these LEDs up to their maximum brightness, without this overheating itself too much, that will be very interesting. Without needing aluminum radiator to dissipate the heat on this regulator that I'm having here. That will be very cool. Look how cool it is. That is some shadow from these resistors there. All right, so this is an exemplification of the circuit that I just made. You can read all of this stuff if you want. This is a starting circuit. Actually, I have it as a standalone circuit from the datasheet. Let me actually find it. Okay, so this is the circuit from the datasheet. As you can see, it's exactly the same as that. One resistor here, and the adjust pin is after that resistor, exactly like this here. And this circuit as well, which is a bit probably different. This is 12 ohms. This is 1.2 ohms. and this guy used 2.2, and then after that 10 ohms there on that resistor. Depends how much amperage you want, how much current you want on the on this line, on this end, on this V out end. Here I only linked the adjust link to the LEDs. This is showing a default and restricted voltage plus current flow using only this simple configuration. So exactly as I made it in my experiment on the table. Hopefully you've seen that, paid attention. It's the same experiment. These are the LEDs. This is the circuit for it, and this is the voltage that I used, and also the amperage is very, very low. Here I'm controlling the adjust current. I'm not leaving it by default. By default meaning like this, the default unrestricted current flow. I'm using the maximum 32 volts of my variable power supply unit for all the experiments. As you can see here, all the time I kept this maximum voltage all the time for all the experiments, using 10 mega ohm resistors for both resistors here on this experiment. The brightness, I randomly choose a 2%. This is the constant current regulator circuit diagram that you've seen already, and let me search it here as well. So here it is. This is the circuit diagram, and this is the 10 mega setup. I have 10 mega ohm resistor, and look how bright is here, and you see, when I'm using 1 mega here, when I'm using 100 here, and when I'm using 10 kilo here, the brightness is higher and higher. And of course, if I'm using 1 kilo, it's even higher. It's starting to blinding you. That's when, at around 1 kilo. Still, with the 10 kilo setup, what I'm having here, I'm purposely shortening both LEDs to demonstrate the constant current regulator circuit. Compare the, to be able to understand what is going on here, compare the luminosity of the working LED, this LED, with that LED. What is there? With the image with both LEDs working, the luminosity is the same per each LED. So if I'm shortening this guy, this luminosity is exactly the same as there, and if I'm shortening this LED, the luminosity of this is exactly as here. It didn't change that much. Well, in picture probably in the image here is different from there, but this one definitely is the same. And in reality also is exactly as in my pictures that I'm having here. This is made mainly for myself. This is a personal file that I'm having here. All right, that's it. This is it for this part. Thank you very much. Bye bye. Yeah, very, very cool project. I like it. I like it. All right, thank you very much for watching, and see you later. Goodbye from your favorite artist electronist, Mr. Q12. Bye bye.